Good afternoon, everybody, and welcome to our session this afternoon on incident response in the cloud. I'm Jim Jennis. I'm Solutions Architect with Amazon Web Services. Very pleased to be joined today by Conrad Fernandez from Johns Hopkins Applied Physics Lab. He's the Cloud Cybersecurity Lead. And for the next 50 minutes, we hope to share some information with you on incident response in the cloud. Basically, three elements to this presentation. Going over just some level-setting basics of events and incidents. Based on the ITIL definitions, things that go bump in the night. Some best practices for incident response in the cloud, and then finally, the real meat of this presentation is Conrad's presentation on information spillage response, and as it's run by Johns Hopkins Applied Physics Lab. Nothing magic here about incidents. In the ITIL definition, all incidents are events, but not all events are incidents. And when you look at event management identifies various events that are occurring within your infrastructure, and then some of those may or may not qualify as an incident. Below you see the typical standard NIST definition of incident response, and that's basically what we're following here in terms of detection, analysis, and identification. So what's an incident? Basically an unplanned interruption to any IT service or reduction in quality, or a failure of a configuration item that's not yet affected the service is also defined as an incident. For example, you have RDS, MySQL, and AWS. If you deployed one of those read replicas and that failed, the failure of health of that would also be considered an incident. So not maybe a security incident, but nevertheless a disruption of service. What we want you to understand here from the beginning, bottom line up front, is that although incident response may be complex, there's absolutely, positively no rocket science involved or needed. What you're doing in the cloud is going to be very, very similar to what you've experienced on-premise, only with some added benefits that the cloud brings you. If you're familiar with Amazon Web Services, you've seen this diagram over and over again about the shared security model, where our AWS as a cloud service provider is responsible for the security of the cloud infrastructure. You as a mission owner are responsible for the security in the cloud of what you deploy. Basically, what we want to talk to you about today, we'll focus on one of these, primarily incident response of the customer in the cloud, which Conrad's going to cover. But there's four scenarios you need to configure or think about. That is the incident response by you in the cloud, incident response of us, the cloud service provider, AWS, for the cloud infrastructure, and perhaps joint incident response coordination of the customer and the cloud service provider in cooperation, or even in a large-scale case where maybe there's been a zero-day identified where you would have joint coordinated incident response by multiple CSPs and customers. Every incident response, regardless of whether your accreditation regime is federal, as in this example, or DoD, or whether it's another accreditation regime, whether it's PCI, SOC, HIPAA, et cetera, you are going to have some applicable governance standards, and those, you should be familiar with those. These are examples from the federal community, documentation that governs incident response. And I have this as a homework assignment for anybody interested to go and please review, for whatever accreditation regime you have, what your governance is. There's going to be multiple stakeholders in any incident response. This is, for example, just taking the federal accreditation for cloud service providers as an example. And it shows that for FedRAMP, with the governance, the agency involvement, the cloud service provider, you as a mission owner will be involved in all those areas. You will be a stakeholder in every single area. And you could substitute that FedRAMP regime for whatever your governance and accreditation standards are, but your involvement will be there. Similarly, how's that governance documented and reporting governance? This is an example from FedRAMP and NIST, which basically shows the integration of all of the elements of that accreditation standard and reporting standard, whether it's US Cyber Command, US CERT, FISMA standards, et cetera, into the incident response regime. You can, as I said, insert whatever policy, process, procedure that you have associated with whatever accreditation regime that you're using the cloud for. So if you're PCI, SOC, HIPAA, you're going to have a different substitution in there. Within FedRAMP examples of this, so we're talking about in the federal government, there are standards, there's 17 families of NIST 853 controls, and you are going to be dealing in this particular scenario with incident response with 9 of these. And Conrad's going to cover specifically implementations for IR4 and IR9, which is information spillage and incident handling. Basically, the bottom line on incident response in the cloud is just like you would be on premise. Jeff Bezos, our CEO, Andy Jassy, say, prepare for failure because failure is inevitable. Failure is going to happen, and you have to plan for it because it's guaranteed to happen, whether that's an infrastructure failure or an incident that occurs. So what we're going to talk about, myself here, before bringing Conrad up to discuss in detail the implementation standards, some topics and best practices. So is incident response in the cloud really any different than on-premise, and if so, how? Talking about some best practices in building IR policies, governance, plans, procedures, and runbooks, preparation, training, and execution, and actually repurposing incident response for continuous improvement. And the example I always use in this is, and we'll see this later, is using the National Transportation Safety Board investigation of, for example, aircraft or transport accidents. If you look back at the history of aviation, safety has been continually improved, and it's been through the ability of the NTSB to deconstruct in detail what caused those accidents, improved aircraft design, improved crew training, and that's what we're talking about with incident response, is to train the way you fight and learn from doing these after-action exercises to improve. And the cloud allows you to iterate and automate this and do it in a very rapid way so that you can learn very quickly, cheaply, as we say in AWS, fail fast, and engaging your cloud service provider. So let's take a look at some of these best practices. Cloud considerations. So cloud is different. And incident response in the cloud is different in that it is easier, faster, cheaper, more effective, and able to be automated. So your ability to actually detect, react, and recover can be greatly enhanced by leveraging the cloud. Using the tools that are available to you in AWS, you can almost totally automate incident response. And if you are intelligent about doing this and using learning, the capabilities that you can leverage in the cloud are much superior to an on-premise incident response capability. In fact, many of the capabilities are possible only in the cloud. And it's, as I said, IR in the cloud is not about just being reactive to incidents. It's about being proactive in planning. So, some best practices. As I said before, what we want to emphasize here is not a reactive process, but actually integrating your incident response into a continuous improvement process. Continuous improvement is required by most accreditation regimes. For example, if you're accredited under FedRAMP or NIST or DoD RMF, you're required to do continuous monitoring improvement. Why not integrate incident response into that continuous monitoring and improvement process? As I said before, like thinking, for example, of using every incident, every event, like the NTSB uses aircraft accidents to investigate and improve. In terms of those being prepared for incidents, we're talking about being proactive rather than reactive. Architecting and designing for failure and incident response throughout your infrastructure. For example, AWS recommends multi-availability zone deployments. We recommend that people define security groups, quarantine security groups that basically allow you to take a suspected instance offline, immediately quarantine it, substitute a new instance. Regard with that, ubiquitous metrics and automation. Measure as much as you can and automate everything possible. We're talking about also clear, lightweight governance and ownership. There should be clarity in every policy for governance that you write, and that should be integrated into your entire incident response architecture. Building for speed and agility, clear, simple controls, leveraging the principle of least privileged as needed, so that, for example, you're talking about delegating the ability to control the APIs in Amazon only to those people who need those privileges and only as long as they need them, and validating your readiness with tests continually. When you get really advanced, we advocate that you consider chaos engineering. So what's that? It's intentionally integrating perturbations into a production system. For example, Netflix, one of the more advanced customers that AWS has, they have something called Chaos Monkey that they intentionally kill production instances and introduce failure into their production infrastructure. And when you get very advanced in incident response, that's something you might want to consider. In terms of governance, tools and owners and administrators that can identify quickly who needs to be contacted, what they need to do, and to use the metadata that's available to you via, for example, AWS tags, so that you immediately know from your infrastructure what that infrastructure's function is, who is responsible for administering that infrastructure, so that it can quickly handle those instances. And finally, this is always a problem with folks, is creating policies and procedures and governance that you aren't willing to enforce. So if you're going to be creating something that's a policy, you better be able to and prepared to enforce it. There's many ways that AWS provides for you out of the box to give you incident response capabilities, and you should look at and use all of those that are available to you, and also be aware when you need to engage your cloud service provider. DevOps is big today in the development arena. When you're developing new code, testing new code, validating new code, why not apply the same DevSecOps principles to incident response? Leveraging what you already do well, start small, growing in, incrementally building, testing, and iterating. What we talk about, or I like to say, this is like building an IR flight simulator in the cloud. Very cheap, very quick to do this in the cloud, to build a complete simulated environment and you know, blow it up. Put those improvised explosive devices into your flight simulator and be able to develop and iterate and improve. So how do you go about doing this? We advocate building what I call an incident response scenario catalog. Simulate issues that identify issues that are important to you, maybe based on historical trend, maybe based on your application architecture, leveraging the folks in your security regime, your users, your ops people, and then build these realistic simulations. Invite other stakeholders and run these simulations live in your IR flight simulator. And then complete an after-action hot wash, and then continue to iterate and improve on that. Very cheap, very easy, very powerful way to improve incident response and use the cloud. It says here, good incident response is no accident. We're building here for, talking about building for speed, agility, and security, and using the ecosystem, all of the services that AWS provides to you to control and monitor and put metrics into your infrastructure. Developing thresholds for security engagement in support processes. When you're using that automation, fork off the messaging that is integrated in with your security process to develop rapid ability to identify and escalate where necessary with your incident response team. And as I said, this is just a small example of all of the different services and messaging that's available for you to take a look at your infrastructure, do custom monitoring, and actually automate in, your reactions and responses as needed for incidents. So with all of that for you as a customer, when should you think about engaging AWS support in terms of cloud service provider? When should AWS be involved in your incident response? The answer is anytime an event occurs that may be affecting your ideal operational state, you should reach out to AWS support. There's certain times, these are 4 examples. For example, we're going to require you to obtain permission from us to, you can perform all the pen testing, scanning you want, but you need to tell us that you're going to do that. So that's an example of reaching out. If you uncover a security vulnerability, we want you to reach out. Suspicious emails, if you encounter abuse of AWS resources. But again, those are just 4 simple examples, but anytime you are impacted and your operations are impacted, reach out. Very easy to engage AWS support. We have 4 support models ranging from basic to enterprise support. And this is just basically a grid that shows the SLAs that we offer for those. This is a mapping, for example, from the ITIL roles that are traditionally in the incident response pipeline into what AWS roles that you have, from a cloud support engineer as an analyst, a technical account manager as an incident manager. For example, some of my customers, I function in that role as the technical account manager, that if they have a problem, they're going to call me to help them out. Easy to get a hold of us. Literally, go to that URL, aws.amazon.com/contact us. You sign in, it'll take you right to the support console, and you can immediately contact AWS support. So, bottom line, and I like to use this, so I'm a pilot, and one of the things that I always look at is the miracle on the Hudson. And so that incident was no accident, because Captain Sullenberger trained the way he needed to train to handle that incident. That's the way you need to have incident response in your organization, is to avoid that accident because you're trained to handle the event, handle the incident securely with the right governance, building the right tools, automating, and responding as you need to. So iterating, incidents don't have to be disasters. We do get a lot of common objections into, well, why should I run incident response simulation? Folks say, hey, it's expensive, high risk, can't afford to do live fire exercises. That's what makes the cloud so great. You can build a total flight simulator completely isolated in another separate VPC. You can detonate whatever kinds of incidents that you have within that without affecting your production environment, shut it down, and you're only paying for the time you use. That's what's great about the cloud and being able to do this in incident response. You know, when I was running on-premise data centers for the U.S. Coast Guard, I could never think of actually doing a live fire incident exercise. I didn't have the resources to do it, to blow up something in a real infrastructure like this. So we did a lot of tabletop exercises and drills. They were very valuable, but they weren't as frequent and as detailed as they maybe needed to be. So folks say, hey, I'm understaffed, don't have time for drills. Well, when you have one of these actually occur, you're going to make the time for it anyway, so why not allocate the time up front to be proactive about incident response? Why you should do it? Just include it in the cloud if you're already doing it, if you already got a good incident response programs. Incident response and doing things, actively perturbing your environment helps you learn about your AWS environment. It helps you understand what's deployed, what's going on in a much deeper and richer way. Finally, you know, in the military, troops always fight like they train. And if you train folks to do this incident response on a day-in, day-out basis, when the real thing happens, the folks are going to be prepared to do this. Using incident response as a culture of continuous improvement helps greatly to build out your expertise, to fix real issues, to actually continuously improve. And best of all, you know, cloud allows you to do this all very, very quickly and with minimal investment. So you're not buying a bunch of servers, racking and stacking a bunch of gear. You're able to do this entirely with a software-defined network in the cloud. So some AWS Security Resources we have for you. Thousands of pages of really good resources all throughout AWS. These are some that you might want to be looking at for incident response and compliance. So our compliance website, security website, the AWS Security Center, and finally the AWS-security at Amazon.com. That's direct contact information that goes right to our security team. Some other readings, if you're in the federal government in general, there's readings. The SANS Institute has some really, really good material on incident response and white papers, first.org, and the US CERT program. So with that, very pleased to introduce Conrad Fernandez from Johns Hopkins Applied Physics Lab, and Conrad's going to tell you about how this stuff is made real in Johns Hopkins Applied Physics Lab.
Thank you, Jim. All right, good afternoon, everybody. As Jim introduced me, my name is Conrad Fernandez. So I don't know about you folks, but one of the most striking words that came out of Jim's presentation, and by the way, he laid a fantastic foundation, is, for me, it was chaos monkey. And primarily because I think when I was growing up, my mom called me that. Apparently, I was a hellion. And I didn't know I was going to be one of those ethical hackers and penetration testers, and essentially seem to have a knack of bringing down systems in my security role and otherwise debugging and testing roles. My name is Conrad Fernandez. I represent Johns Hopkins Applied Physics Lab. As you may have guessed, I'm a security geek, admittedly. And I'm very excited to be here because in a lot of my roles prior to APL, which included over 7 years at Booz Allen Hamilton, and working for Defense Department and various three-letter agencies, we even never talk about the cloud. The cloud was not secure, not safe, and what have you. And it's been an eye-opener in the past couple of years, especially. I'm sure there's a lot of talks that you heard on with Brett Miller's team and DFARS and the NIST, guidelines. And so I'm here to tell you that wearing a security hat and cloud is both possible. So without further ado, since I'm with APL, and some of you are wondering, what is Johns Hopkins Applied Physics Lab? I think most people would have heard of Johns Hopkins. But the Applied Physics Lab is a university-affiliated research center, and the university that we affiliated with is obviously Johns Hopkins, and we're based out of Central Maryland. I'm sure there's folks that weren't aware of this, so now you are. And if you're wondering what type of missions we work on, it's really very diverse. We have civilian space, so we are similar in the sense to JPL. I'm sure a lot of folks have heard about Jet Propulsion Lab too. We have a very deep science and space offering. But we also have air and missile defense, and we have naval and underwater and undersea operations, cyber operations, very big now into national security and national health. And I'll talk a little bit about that too. But as you can imagine, our sponsors are several US government agencies, the IC community, NASA, obviously for space, DHS, DoD, and several agencies. So what do APL missions require? And I alluded to, we're moving to the cloud. Well, the number one thing we're seeing a lot of is the ability to quickly, a lot of our departments really want to have elastic infrastructure that's spun up. And as you can see here, I've put layman terms. So we're talking about elastic infrastructure, we're talking about scalable computing, both vertical as well as horizontal scaling. And they're using this for medical imaging processing, because we also work with Johns Hopkins, in Baltimore, big data analysis, machine learning, you name it. There are a tremendous number of science projects coming up. With agility, I purposely chose to use this particular adjective because as a developer and with small teams, it's the services that are available with Amazon. And as you can see, the icons on the right side, things like CloudFormation and the stacks that are built, as well as the ability to pre-configure and pre-bake your in Amazon, it's the machine images, and having the ability to bootstrap your various software besides the typical HTTPD and the LAMP stack. You can write all sorts of scripting, and that piece is really powerful, and we're really starting to embrace this more and more. And all this while maintaining security and governance. Now, as you can imagine, that is one of my major roles at APL. And this is what we live with on a daily basis. We provide multi-factor authentication. MFA is very big. Security groups, access controls, data encryption, security monitoring. I'll be talking a little bit about that. But every one of these items here, and some icons are shown on the right side, which include key encryption, SNS notifications, and you can see CloudWatch alarms. Each one of these, you could easily spend a whole day, and I'm sure there are several talks on each one of these items. But the point is that you have a plethora of security and governance. While, and this is also becoming very important, we have requirements now for some of our medical projects to be HIPAA compliant. And I'm sure you're going to hear a lot about the US Gov Cloud too for sensitive CUI, FOUO type data. Moving along, so I've told you what the missions require. So what does the APL Cloud team provide? So I'm one of those people in there. We have like 4 people. Yeah, you have to recognize which one of those is me. But really the point of this particular slide is that we start small. And the key thing is there is a lot you can leverage in terms of the resources that are available to you. My first reInvent in 2016 was another eye-opener. Events like this, the summit, you can learn so much and you can bring back, and if you understand how to do automation, that really helps a lot too. And we also reach out to our resources. So our TAM, as it's called, our technical account manager, Jim Caggy, for example, points us to a couple of new things that I'm going to talk about AWS organizations, to utilize, and we can do that. I met Brett Miller in the NIST workshop. He pointed out the stack, and while this is notional that I've shown out here, we've also built out the 3-tier DoD NIST 853 stack, and that's worked out really well. And that's a segue to, again, I'm only going to be talking about incident response. So, before I get to talking about the phased approach we used, I wanted to set the proper context for the differences between incident handling and information spillage response. These, by the way, are not words I've created. They're in the NIST and the FedRAMP. In fact, Jim really did a good job just outlining all of those, but there's a lot of details up on the website. What I wanted to point out some of the very important differences between the two, in case folks were not clear on what spillage is versus incident handling. So IR4 for the most part, and we have a SOC at APL, and I'm sure a lot of you folks. Actually, how many folks here actually work or are related to incident response and SOCs? Oh, quite a few show of hands, okay. Very good, but that's only half, and for the other half, we don't know. So for most of us in the SOC, life's a real breach, and you're always looking for the suspicious and the highly suspicious, and you categorize these different events. So the point I'm trying to make with the life's breach part of IR4 is that it's usually difficult to detect very sophisticated threat actors, and they use evasive techniques and exploits. Eradication can be very difficult, again, because you're not sure of the extent of the foothold. I don't think any company can admit to knowing just how much foothold there really is in the case of IR4. And there's lots of lessons you learn about this tactics. Whereas the spillage is a little bit different. This is usually, for the most part, inadvertent. It's a spill. Cleanup on aisle 9, honestly, is really what's going on here. The sort of good news is that, for the most part, you're always notified. There's always self-reporting, because we're talking about classified information that's being spilled onto unclassed systems. And the eradication follows the DoD lines. So there's a lot of documentation on that. And the follow-up is, again, because it's DoD processes, there's lots of official paperwork. So hopefully that's clear. Moving on to the actual phased approach, this is what we do. Some folks that we've talked to, and including the DIB partners that we engage with, DIB, for those who are not aware, is the Defense Industrial Base, a lot of contracting firms that we collaborate with, pretty much go through this process, which is preparation, identification, containment, investigation, eradication, recovery, follow-up. What I did not show here, which we take for granted, is there's a loop from follow-up up to preparation. It's an OODA loop, really, because there's some lessons learned from, especially after a breach or even a spill, for what you can do to better prepare. And so that's the takeaway here, is you come up with a process, and I'm segueing into the preparation process, which is one of the most important pieces. In fact, a lot of the other IRs, and Jim talked to quite a few of them too, training is very big, and using simulations. I think they call it SIRS. We call it something else. But the point is, do tabletop exercises. Train your folks to handle. But in the cloud, you also have to make sure a lot of these are set. So pragmatically, we set them. Jim showed you a slide where you see these pretty slides with VPC flow logs, CloudTrail, AWS config, SNS notifications. I would also add OS and application logs. So one of the things we're always on the hook for, and we have no excuses just because we're going to the cloud, and the cloud may not always reach back onto our hybrid and onto our on-premise network. But we still want to collect OS logs, whether it's Windows systems or Linux systems or your web servers, whatever you're running in your cloud, collect OS application logs from your EC2 instances. That's a big suggestion. And collect and aggregate your logs centrally is, I think, a best practice to have them from your various VPCs or various AWS accounts, if you have sub-accounts, and I'll talk to that a little bit in subsequent slides, so that you can then aggregate it for correlation, and you can do things like Elasticsearch. Or in our case, we use Splunk, and I'll show you a few examples of that. This second last bullet is really key for those of you doing spillage, because if you encrypt your data with KMS keys, that's a great way to effectively sanitize your data. If you delete the keys, your data on the disk is garbled. And so you can still go ahead before you delete the keys to wipe, and I'll talk about wiping techniques too, or sanitization techniques. But if you use data encryption, that's a really good thing. And consider multiple AWS accounts. I want to talk about this because this has really helped us. If you went to reInvent, this past reInvent, this was one of the new features that was announced. So Jim Caggy TAM pointed that out to us and said, hey, Conrad, you might want to consider using this. So I arranged a meeting with our folks at APL, and we ran with this. And the first two bullets really talk to is the why. There's a very clear separation of duties for your different projects. In fact, in the next slide, I'll show you how we organize it along organizational units. But the reasons are you can limit the blast radius. So one account, one project, let's say in Space Department, gets compromised. It doesn't affect the folks that are working in air and missile defense or cyber operations or any one of the several departments that we support in the cloud. And I give you an example here for the types of overarching policy you can set. So we own the parent account. So we got the power, right? And that's important for you if you're going to do this, is that you can set these policies. In this case, I gave a simple example of not deleting the logs, so that regardless of any of the accounts that are spun up underneath you, you can make sure that the cloud trails are not deleted, the VPC flow logs. This is an incomplete list, obviously, but it's an example of how you can deny sub-accounts under your parent organization to not tamper or, willingly or unwillingly, wittingly to delete critical data. Here's an actual screenshot, sanitized. But what I wanted to highlight was it's really actually a very simple construct. There's only two parts to it, for the most part. And that is on the left side is something very closely related to how you have your Active Directory, but it's not the same thing. It's similar to it, where you can organize based on your departments, projects. That's kind of what's shown on the left side of the screen. And the right side of the screen are policies. So just as an example, you can apply a HIPAA policy for those projects that require data to be, they're HIPAA compliant. You can have conditions in those particular policies that says must use AES 256 encryption for your data, so that your data is encrypted and you meet the standards. So hopefully this is an important, if you get nothing else from this talk in terms of preparation, I hope you can consider something like this, because we find this very useful for all the projects on the left side. And it's a many-to-many relationship, so you can apply one or many of these policies, governance policies, to one or more of the projects that's under your governance in your organization. So moving along to the next phase, which is we call it identification, but in many circles also known as detection. Just want to point out the differences between the two. I alluded to it earlier in pointing out the differences. This is key because in incident handling, it's a lot about the type of rules you would use to detect, and you would typically employ some sophisticated SIEM tool. Because we use Splunk. You could use AWS's Elasticsearch, and use Kibana for visualizations. And on the spillage side, you really have data loss prevention is one way you can detect, besides being notified by the CISO and the users themselves when they discover that classified information has been leaked. And here's another important point. Open up a case with Amazon support, and Jim talked about that too. It's always better because they can verify any of the services that you call to sanitize later. They can verify on Amazon's side as well. Here's an example of a screenshot for identification. So identification. And if you can't read it, it's fine. But this is what the dashboard would look like when you can, and showing S3. It's showing a bunch of different constructs within Amazon. Then this is specifically Splunk for Amazon, for AWS that you can, and it's different than the on-prem that you'd have to buy typically a separate license for this, for the data that's stored on Amazon. The next two, containment and investigation. And in interest of time, I lumped these two together since I think I only had about 25 minutes. So really quickly, containment, which is, you can see mostly the steps that are listed there at the bottom. This you can apply to anything. This is really a useful feature. This is probably one of the most useful features in Amazon, is the ability to really quickly apply an isolation, what I call an isolation security group. So you can use this for live box forensics, which is for regular IR4. You can use it for spillage too. Because if you know that something, in the case of spillages, when you have to go in there to do the cleanup and the DoD sanitization, you can just quickly apply rule sets that only allow SSH on port 22 or RDP on port 3389, and with no egress. And hopefully you can take other courses on how to exactly implement this part, but that's the key. And we also only come in from a particular enclave, so that if it's compromised, or in case of other IR4, that that there's no other inbound other than the men in black that go in there, so to speak, all the investigators to do the cleanup. And in investigation, I just threw in another example in Splunk here in this case. If you can't read it, it's fine. It's an EC2 instance, and in this case, I'm just searching for myself, so I'm investigating myself. And the point here is that it shows you the relationships of that EC2 instance to the networks, security groups, the various roles, and what have you. So Splunk, or again, if you're using Elasticsearch and Kibana, it's the same idea. Everything is, the key part is in an investigation. You should use something that does correlation. Moving on to the next step is eradication. And this is where the spillage folks, and I'm only limiting the spillage because eradication for regular breach type is just way beyond the scope of this discussion. We need another half an hour for that. But to keep it simple here in the case of spillage, what you want to do here is the general approach is you first copy a DoD's approved tool, like BC Wipe. I specifically use BC Wipe because it's an approved tool. You can go Google it if you're curious about it. So it's a good wiping tool. And you can very quickly use automation. In this case, I gave an example of secure copy. So it's really going over port 22. Again, remember, we only allowed 22, and in the case of Windows machines, 3389. But you can secure copy using, obviously, the PEM key, which is what the host private key is. You can copy the tool onto the target host and put it on the root drive so that in the next step, you can remote connect to your host using that SSH-i PEM key, and you can get to that host. And once you're on that host, then you follow all the BC wipe procedures in the case of sanitization. And the beauty, the real takeaway of this is that it's really fast. You can do all this stuff that is probably a little more challenging to do on other systems. But Amazon gives you this really quick way to do this using these techniques. Oh, and if you have any secure data and you have KMS keys in there, encrypted data, delete the keys is another final step. Last two phases are recovery and follow-up. And in that case, all you have to do is the reverse of the isolation for recovery. And so when you were containing your system, hopefully you backed up what the previous state was. So once the sanitization is all done, then you just restore the original security groups to make life back to normal. And follow-up is, again, lots of paperwork, lots of lessons learned. In fact, I think some organizations call this phase lessons learned, but we just call it follow-up because there's a lot of reporting to all the CIOs and security officers and what have you. Fill up all the paperwork. You have a nice clean report, and if you have a major breach, then hopefully you have a good story to tell, you know, like RSA and other organizations did in 2011, back when we were working those cases. And so those make for really good stories. And again, if you're using spillage, then you'd have to follow DoD 5220 because they have a lot of very strict regulations and procedures to follow. So final takeaways in this very condensed version of incident handling is really understand the differences between IR4, which is threat-based, and IR9, which is spills-based, and plan and handle your response accordingly. So typically, you will also have two different teams because the type of work you do for dealing with very sophisticated threat handling, and we actually have different teams at APL to do IR4 versus IR9. And you should always use a phased approach. The one thing I like about our phased approach is that, again, we can fit in the necessary pieces based on which team is doing what, based on IR4 versus IR9. And so the main thing is make sure you have your standard operating procedures, your SOPs, and just define them well using maybe some of the automation examples that I've alluded to here. And of course, train your team. Make sure you do tabletop exercises because believe me, if you don't do things like, you know, a spillage cleanup exercises when it does happen, it can cause some consternation. Preparation is critical. If you don't have things like knowing how to store your private keys and all these things we just take for granted, because you know, if you do them often enough, you know how to do it. So if you don't have logging, you're not going to be able to search anything, right? So you want to make sure you have all these, the critical infrastructure part of it set up, setting up trails. It takes some work, but you really need to have all that done and even decide what your search mechanisms are going to be. Like I said, one thing I didn't really talk about a whole lot is AWS CloudWatch, which is mentioned in here. You could use, Amazon keeps improving CloudWatch. So you could, in fact, do a lot more with CloudWatch in this CloudWatch rules. And so if you didn't want to forward a third-party SIEM tool, you know, like Splunk or someone else, again, I get no commission. So you know, you use whatever tool you want to use. But if you can't afford it, just write some really clever rules in CloudWatch. You'll pay a little bit for it, but it may not be as much as others. Or you can have the Elasticsearch, which is effectively Amazon's Elk Stash, you know, again, with the logging and the Kibana visualizations. I think those work really well as well. And as far as possible, again, use the CLI or the SDK as the equivalent. Whether you use Java, so we like to use Python actually, and we use the Python SDKs or the CLI, And then you can automate those, isolate, using isolation security groups, modify your instances so that they only have those particular security groups that have very restrictive, inbound rules and no outbound, and then you're good to go. So the real takeaway is that incident response in AWS, we feel, is very agile, and it can be very effective if you know how to do these things. So obviously engage, services, professional services if you need to, or whatever help you need. Go to these conferences, do all these, research. And so even with a small team, the very Spartan team that we have, we enable this a lot for the various teams to be able to effectively do the incident response. And that's really all I had. And are we going to be able to?
Yeah, we're happy to answer any questions that you might have, either of Conrad or myself.
Yes. So thank you. Are we going to take it down, or are we taking it up here?
We can just answer any questions that you might have, or if not, thank you very much for your kind attention.
Thank you, and we're open to questions.
One quick question. Do you have experience with spill cleanup on an S3 bucket?
Yeah, so the question was, for those who didn't hear, is there any procedures for an S3 bucket? So that's true. What I talked about here was for an elastic block store. Yeah, so that's a good observation. We haven't articulated all the processes for cleaning up S3. Having said that, if you map S3, I don't know if, for those who are not familiar, you can map S3 exactly like you do any volume store, right? You can use either a third-party tool, like we use TNT Drive on a Windows machine, and we would effectively do the same wipe procedures on an S3 bucket. And so in S3, you can also encrypt files, of course, so you would actually delete. So I didn't get into the types of encryption. So whether you roll your own or use Amazon's native S3, like we map our S3 drives to like S drive. We would go ahead in the S drive and just run BC wipe on it and clean it. The nice thing about S3 is that you don't have to go into a particular machine to do that. So if you know it's leaked in S3, you can use any mechanism to quickly get to S3, and S3 is in S3. So hopefully you have bucket policies that have protected it. Again, we didn't talk about how you protect your native data, whether it's in an EBS volume or whether it's an S3, but you would go ahead and run the BC wipe on it, like you would, and sanitize the files that way. Hopefully that helped. Okay, good. Any other questions? Yeah, sure.
So if you have like a monitoring tool like Splunk or something like that,
Mm-hmm.
do you have that in the cloud when you monitor just in the cloud, or do you have that on the ground? You have messages come down, it's your own time.
So that's a good question, because this presentation was about monitoring in the cloud. We believe that it is important to also monitor native stuff, and the Splunk, at least the Splunk version we use in the cloud is native. We also have an on-prem version of Splunk, and the two don't talk together, and partly because we have some rules about how things go back and forth. In the future, it's probably good to have both of those correlated. We haven't decided where that's going to be yet. So right now, they're isolated, if you will, and just by design. You're most welcome. So that's by design. But that's a really good question, because we haven't solved the complete hybrid, one pane of glass for a complete hybrid solution. Great question.
So you mentioned Chaos Monkey, which is a beautiful set of tools.
Yeah, that's my nickname.
The Symbian Army is great, and what they do in terms of forcing you to do specific things so your network doesn't self-destruct is great.
Mm-hmm.
Has anyone taken the automation of not quite penetration testing, but certainly chaos testing of intrusion to that level and made it that easy that you know of?
Why don't you take that?
Yeah.
Please take that.
Not that I'm aware of, and so I support Department of Defense, federal government, et cetera. So in my customer base, not that I'm aware of. So not to say that there aren't folks who haven't done those kinds of advanced things, but in the customer base I serve, I'm not aware of any.
Yeah, so do you have your mic on? Okay. Yeah, go ahead.
What type of spill was this? Was this an air gap spill or electronic spill? I'm trying to understand how you got a spill.
So we don't talk about the mechanisms of how you get a spill, but typically you get an email. You get an email with a file attachment that wasn't it's usually inadvertent, meaning that the file was misclassified. In other words, it was marked as FOUO, perhaps, but if it's later analyzed, and so you see some of this in the press, right? You see some of this in the news. It's later deemed as, hey, this should have been classified. So that's typically what happens. Or sometimes, I hate to say this, there is a classified document that's sent by mistake. So it's a mistake. The key difference is that well, the person meant to send it, but they didn't mean to send that particular file as part of, usually it's an attachment with other attachments. And so it makes its way out of the system. I can't tell you how because we're on the receiving end. We got to go and clean it up, but we didn't cause the spill. Yeah, I probably should have said that. I took that for granted. Did you want to add anything to that?
No, that's
Sure, I'm sorry. I forgot.
Sometimes we find out about our data breaches sort of like a long time after they happen.
Right.
And what do you do about data retention? It gets expensive after a while.
Yes, that's a great question. In fact, on our on-prem versions with the, like we use NetWitness for packet capture. I mean, again, I wasn't going to talk about all the tools. We can't possibly, with the amount of traffic we get, store more than 3 months. So I think the rule is now we got to store 6 months. So we have to contact the vendor because it's all on attached storage. So keep in mind on the on-prem, we don't have PCAP on the cloud. We haven't come to that point yet. We don't have full packet capture. We have all the logs and everything I talked about. I wasn't kidding about that. But we're not exactly like on-prem, which is more robust. But we try to keep at least 6 months. I think with federal regulations, you'll probably have to keep longer, right?
Well, and that's what I was going to add is depending on what your regulatory governance is, you need to retain those files. But for example, in Amazon, one of the things is that you have a choice of storage options for that. So you're not buying a multi-terabyte SAN array and paying for it. You can take this and store it in S3 and then set a bucket policy, an archive policy to, for example, archive that after 30 days into Glacier, and then you're paying at sub cents per gigabyte kind of storage cost. So yeah, you're going to be storing the data, but it's going to be right. It does, but it's a lot cheaper than putting it someplace else. But and it's one of those things where you got to look at what your regulatory policy is and what you have to do. For example, like I mentioned before, I worked for the Coast Guard before AWS, and we had like an event like Deepwater Horizon, Hurricane Katrina. All that data has to be saved because it's going to be involved in legal events years from now. So having cheap storage is good. So, yes, thank you. Thank you very much.
Thank you very much.